Act alive. It's alive.
When the wave has moved halfway from here to here, then this point is going to be here, as you said, which means that half of that arc is going to be like this, and then the other half is going to have to be like this, right? You know, this arc, of course, you could think of, well, let's pretend it keeps going. If it kept going, it would be there, right? Okay? Then where's the reflected arc going to be? It's going to be on the other side, right? So it's going to be like this, moving this way. Right? Okay? Okay, well, in this case, here, the total wave would be the superposition of these two. It means you just add the two functions. Okay? So at every point, you just add the two values of y, the two. So right here is your net wave, right? What do you get for your net wave here?
Oh, zero. A line.
Yeah,
Straight line.
if you add this function to this function, well, they're equal and opposite, aren't they? Where one is positive, the other is negative, and with equal displacements, right? So you get this, okay? Now here, you get the superposition of these three in the ideal case, right? But if the wave looks anything like this, you're already losing a heck of a lot of energy. Okay, so there's a limit to how far you can sustain it. So I'm going to say, okay, this already is probably beyond the limit imposed by energy conservation, so it won't really be this big, okay? So let's just say the limit is actually just like here, okay? And I'll say the limiting amplitude is less than the ideal amplitude, okay? Because the ideal would be the sum of these three, and the thing would be all the way up here, okay? Now when we draw these, we just keep in mind that in order to be able to see what's going on in the drawing, we're actually exaggerating the vertical, if you will, the scale in the direction perpendicular to the motion of the wave, okay? So this is already seriously exaggerated, okay? But in order to see it, if we draw it realistically, you might not even be able to see that it differs from the straight line, okay? Okay, so that's how the wave develops. And you can then see, well, between this state and this state again with the next positive half cycle, the wave will go from this to flat line to this. What's the next state? Well, in the next state, this thing will have moved to where this point is here. And this point on the green, which is now going this way, is here, right? But then the yellow being moving this way, this point on the yellow will be here, right? And there'll be another reflection of the original purple wave, and there'll also be reflections of the yellow wave and everything. So you get all these reflections going around, right?
Yes,
Okay, so what you get ideally might not consist of an equal number on this side and this side, okay? But after a long time, that's going to be the case, okay? So even if it doesn't completely work out with all the possible reflections, when you're starting the wave, after a while the wave will really consist of equal numbers of the original wave and reflected waves on this side and this side. Or at least the numbers will only be off by 1, and if you've already got 10,000 reflections, you know, 1 less isn't going to matter. So that's a little more detailed than you need, but it's going to flatline. Because what's on this side will match what's on this side. Plus or minus 1 reflection out of many. Okay? And also, since those reflections are dying out because of dissipation of energy, the one extra that you might have on one side or the other is going to be minuscule. Am I making any sense at all? That's a little bit scary. Okay. Okay, so what we have then is, you know, okay, we start out with a flat wave, then we get this, then we get a flat wave, then we get this, then we get another flat wave, and the whole thing starts over again, right?
Nelson.
What now?
He said it's a hamburger
Oh man, now you make me hungry.
with an extra patty on the top and the bottom.
How could you do that to me this early in the day? Okay,
Oh my God.
now we all got a break and go get some lunch. Okay. Hamburger. Yeah, you're right, it does. And another thing is, I only eat 1 hamburger a week and it's not until tomorrow, so now you've really got me upset. Okay, hamburger or no hamburger. This is what it looks like. Now, the analogy I was going to make is, if you got 2 people swinging a jump rope, okay? Yeah, of course you're swinging it like this, and it's kind of going in a circular pattern so that whoever's up there can duck and jump and duck and jump, right? But the back and forth motion of the jump rope is going to just look like this, isn't it? It's going to be over there, it's going to be flat. It's going to be over there, it's going to be flat, right? Okay? So I call that the jump rope mode. Okay? That's a fundamental mode. And I might sometimes refer to that as the jump rope mode. Well, the next question is, how does the wave develop if you start driving this thing at a frequency that gives you 2 half cycles? See if you can construct a picture of 4 subsequent waves that represent the motion of this thing.
Restart at still.